Our last press conference today and of the EGU2017 General Assembly. And this is about food security, how extreme weather and other hazards affect what we drink and eat. And as usual, we'll have the three presentations and then we'll open the floor for questions from journalists here in the room or those watching remotely. Taking part in this media briefing, we have Ertu Gersin, who is a project manager at the Water Footprint Network in the Netherlands. Then we have Stefan Frank, who is a research scholar at the International Institute for Applied Systems Analysis in Austria. And finally, James Daniel, who is a researcher at the Geophysical Institute at the Karlsruhe Institute of Technology in Germany. And I'll now hand over to our speakers.
Hi, welcome everyone. Today I would like to talk about how European economy is dependent on water resources outside its borders and its vulnerability to water scarcity and weather and drought. Why this is important? This is important because when we look at the different sectors like meat and dairy or consumer food, for example, rice or meat, we always look at what's going on inside Europe. However, when we look at the outside Europe, actually where the commodities are imported to the Europe, like for example, soybean or rice or cotton products or coffee, cocoa type of products, we see lots of vulnerabilities. This is important because in pan-European level policies, when we look at them from like climate change adaptation policy or agricultural policies, we don't see this interventional dimension in it. Or when we look at the international development policies or trade policies, there is no water issues or weather extremes are addressed. This project is as a part of a project financed by EU Horizon 2020, and is part of the IMPREX, which is all about understanding the climate change impacts and the weather extremes and prediction management of the hydrological extremes. When we look at this is very important to see. Approximately European economy in terms of production and consumption needs 668 kilometer cube of water, and 38% of it lies outside its borders. When we look at this map, we can see that darker blues are the areas where our dependencies are higher. Brazil, Argentina, and Ukraine, or Russia, China, and India and Pakistan. Of course, also Indonesia. These are the locations where big commodities, agricultural commodities, are flowing to the Europe. Of course, when we are depending on these parts of the regions, we can see that we are also vulnerable to the water problems occurring there. What does this mean? The first problem is water scarcity. Many crops or crop products, derived products, are coming from the regions are vulnerable, highly vulnerable to water scarcity. Major ones are soybean, sugarcane, cotton, rice, almonds, pistachios, and grapes. Of course, it has implications. It has implications on the food security, food prices, or sectoral to the businesses which are dependent on the supply of these goods and services. For example, if you look at the soybean, why soybean is important? We are dependent on the soybean for our meat and dairy sector. Our meat and dairy sector is just using the feed from soybean coming from outside Europe, for example, and 98% of our need is coming from outside. And what we researched or found out is that this 57% of it is highly vulnerable to water scarcity, which means when water problems there happening, for example, when we look at the Argentina, the USA, the India, or the China, the soybeans water allocated to in these areas for irrigation can disturb the supplies of goods, soybean, to this country, which means actually the prices can increase because of the shortfall of the soybean, or prices can increase the meat prices in the markets. Or at the same time, maybe we need to look at for different grains for feed for our animals, for example, or maize or other animals, which can also increase the prices of the other grains. So it has implications from consumer side to the business side at the same time. Of course, when we look at this vulnerability, for example, rice or food at homes, is that like 70% of rice is highly vulnerable to water scarcity. You can see in this map is that red areas are where vulnerability is very high and the green is low. So you can see that India and Pakistan are where the rice is coming from, are really highly vulnerable to water scarcity. And also cotton, approximately 70% of the cotton is also highly vulnerable to water scarcity globally. We are not also to water scarcity. Another problem of water is just related is the droughts. Droughts can affect the rainfall patterns, and then not enough rainfall can affect some commodities, production and supply of some commodities outside the borders, which are the most important ones are oil palm, sunflower, coffee, cocoa. When we look at these crops and ripe products, these are really coming to our businesses and our economics. For example, chocolate industry or the coffee industry is really huge in Europe, and short of supply of these can really risk to these economies at the same time. And of course, at the moment, currently, in shorter term, when we look at the drought problems in the areas where these commodities are produced, drought risk is really low to moderate, so there's not a big risk. But we know that it's just like the climate change can alter rainfall patterns and drought in this area. So in longer term, when we look at the policies, we need to address these dependencies and possibilities of these vulnerabilities in these areas of growth. You can see that where we are actually dependent on the rainfall here is that we can also see mainly here is Brazil, Argentina, where the soybean is coming from, and the oil palm, which is Indonesia. These are where we are dependent to the rainfall outside our borders. We are dependent to water resources outside and global water resources, but we also impact those resources, mainly because of the pollution or consumption and or production through the import of the goods, particularly industrial goods, are affecting the pollution or pollutes the water resources outside in the world. For example, mainly in Ukraine, Russia, China, India. Why? Because of the production, we import industrial goods, mines, like steel, like core, iron ores, and or those derived products. They heavily pollute the river basins or the water resources in these areas. This is important. This is important because, first of all, our climate change adaptation policy or our agricultural policies are not addressing international dimension, are not addressing water problems in an international global world. But our international policies or bilateral trade agreements doesn't address water at all in this dimension. So our project or results shows that we are highly dependent, and this dependency causes vulnerabilities, and this is significant for particularly sectors, some sectors like dairy, meat, or cacao or coffee, and we need to address this in our policies, future policies, and our strategies. Thank you very much.
So welcome everyone. I will be talking about greenhouse gas mitigation in the land use sector and potential implications for food security. So just to give you a bit of background, as you're all probably aware of, the land use sector is a major contributor to greenhouse gas emissions. It accounts for around 24% of global emissions, half of it coming from land use change emissions, for example, deforestation, the other half of it being associated to, for example, emissions caused by the production of agricultural commodities. So in order to achieve ambitious climate stabilization targets, the sector will have to contribute, like any other sector of the economy, to these targets by, on the one hand, reducing its emissions, but also by providing additional biomass for bioenergy production. So in this study, we looked at the implication of these mitigation targets and potential trade-offs with food security using an economic land use modeling approach. What we found is that the sector can contribute and that globally coordinated mitigation policies perform better than regionally focused policies only. Also, we found that mitigation of land use change emission is very cost efficient. So on the one hand, you can reduce significant amounts of gases, while on the other hand, you have limited effects on food security. Same for soil carbon sequestration on agricultural land. It can provide significant revenues in terms of food security, so improves soil health and also kind of crop yields, while at the same time significant amount of carbon can be stored in the soils. And last, we found that to achieve these ambitious targets, so the 1.5 degree target, we will have to benefit or take advantage of all options available for the land use sector, all mitigation options, in order to avoid spillover effects on other sustainable development goals aside climate change mitigation. So here's some detailed results. On the x-axis, you see the greenhouse gas mitigation required by the land use sector to achieve a corresponding climate target. in 2050 are this basically the units are gigaton CO2 equivalent, and mitigation in 2050. On the y-axis, you see the implied calorie losses associated then to these targets for the land use sector. And you see that with increasing level of effort, so moving toward the 1.5 degree target for the land use sector, if it were to achieve cost efficiently across sectors, you will have, on the one hand, significant emission reductions required, 8 gigaton CO2 equivalent, and also rather strong impacts on calorie consumption, so around 270 kilocalories lost per capita and day. So we see that this curve is nonlinear, so with increasing level of efforts, we observe higher trade-offs. But we did not only look at global coordinated policies, but only regional policies where only a subgroup of countries takes action. So for example, the points display different climate regimes where, for example, only developed countries take action. And if, for example, the developed countries were joined by Brazil or the countries of the Congo Basin, then their mitigation potential could be significantly enhanced with limited trade-offs for food security. Because these countries are land abandoned, have a high share of emissions coming from land use changes, which can be mitigated rather easily and with low impacts. While in contrast, if these countries, the developed countries, were joined by countries like India or China, which have high intensive agriculture, densely populated countries, then the additional mitigation potential would be rather modest, while at the same time we observe bigger impacts on the food consumption side. We also looked at soil carbon sequestration options on agricultural land, since these options can deliver, on the one hand, significant carbon sequestration in the soil, while at the same time benefiting productivity, soil health, etc. So there is a number of options available for cropland management, improved grassland management, legume sowing, for example, cover cropping, manure amendment, etc. And in the last slide, you see that, again, for achieving this 1.5 degree target cost efficiently across sectors, we would expect the land use sector to mitigate around 8 gigaton CO2 equivalent in 2050. The bar shows the different composition of this mitigation. The green bar indicates the CO2 sequestration coming from forestry and other, or the mitigation potential coming from forestry and other land use, while the yellow and orange bars indicate the mitigation potential coming from agriculture. In a mitigation scheme which does not consider soil carbon sequestration, the triangle indicates the calorie losses again. And here we see that by incentivizing soil carbon sequestration on agricultural areas, we kind of pay the farmers for the carbon sink they provide. We are able to achieve the same amount of mitigation for much lower calorie losses, because farmers remain competitive under stringent mitigation targets, and that's why more cropland remains under production, and this benefits also the food security. And we also considered then, in addition, the co-benefits explicitly of soil carbon sequestration on productivities, and this again brings down the impact on food security slightly. So to conclude, these options are essential for kind of efficient policy design with respect to climate policies and food security. Thanks. Mm-hmm.
Good morning, everybody. Today I'm going to talk to you about wine. So it's a highly vulnerable industry, but we've tried to look at this from a different perspective by having geophysicists, geoscientists, meteorologists, economists from Europe as well as Australia attempt to develop a risk index for each wine region in the world. So wine brings Europe, Australia, and the world really closer together, but it's a huge industry. It's $300 billion in terms of direct GDP, with an additional $350 billion in induced GDP. There's huge partnerships across governments. I come from Adelaide, which is a huge wine region in Australia. Germany, the same. They have a huge wine industry there. And they've now developed partnerships just on the wine industry to see how we can learn from one another. Where and how much wine is grown? So there's 131 countries around the world now that produce grape wine, and about 26 billion litres are produced globally. And up until now, we had about probably 80 or 85 countries in most databases around the world. We've tried to add countries where they're starting to develop, such as Ethiopia. Well, Ethiopia's been since 1950, but then Thailand, Nepal, Bhutan. There's a lot of countries that are starting to get into wine. Now, an average of about 10% of wine production per year globally is lost via natural hazards, and these are from all different types of natural hazards. So it's an extremely vulnerable industry. The main ones are earthquake, drought, climate and heat wave, storms and tornado, including hail, bushfire, biological and chemical problems, but also then frost. So frost is one of the key loss components of natural hazards for the wine industry. So to build a global risk index for wine regions, we've tried to look at the natural hazards, we've tried to look at the historical losses due to natural hazards in a lot of different locations around the world. Hail has caused major damage across the globe, also in previous vintages. So from 2012 to 2016 in Burgundy, a lot of the vintages had up to 50% of their crop lost to hail. Earthquakes have caused losses in Chile. So in the Chile 2010 event, 125 million litres was lost. Frost, like last week's events across Europe, Switzerland, Austria, Germany, Hungary, all of them had huge frost problems, and they're probably going to lose up to 30% of the crop, although from Germany we've heard up to 60% of some crops in some vineyards. And climate change impacts occurring, meaning that harvest times are going to change and the suitability of vineyards is always going to change. So to build this global risk index, what we did was we looked at 7,500 wine regions around the world, built up this database, and this contains about 110,000 wineries, and examined then a stochastic model for each. So we built a model for hail, a model for frost, a model for earthquake, and then did it on a country-by-country basis to develop this risk index. So in terms of earthquakes had about $5 billion in losses globally in the last 6 years, but many savings can actually be made by just a few dollars of better practice. So by putting ties around your rare wine collections in wineries, this saves a lot of money because it's the low-intensity events, the frequent events, earthquake events, that cause damage by bottle breakage. And so vineyards can actually do things to really reduce these losses. Of course, in terms of the earthquake index, California comes out #1, Chile and Japan. Japan actually has a thriving wine industry, and these have all been affected by previous events in the last few years. In terms of hail, so we have seen an increasing trend in southern Germany and France in terms of hail. We've also seen a trend of increasing losses. And this is a huge problem that the Burgundy region has actually seen, and the Burgundy region has decided that they will put in hail cannons. This was also decided on about April 15th that they're going to put in hail cannons across the whole Burgundy region to try and do cloud seeding, which is putting silver iodine up and then hopefully reducing then the hail before it happens. But whether this actually is possible or not is another thing. Hail netting can be put across the vineyards, but again, this is very, very costly, up to 20,000 euros per hectare. And so Burgundy has decided on this simpler option. Whether this will work or not, again, is a study that has to be done in the future. In terms of hail indices, we see Mendoza in Argentina is very high, as well as across Switzerland, northern Italy. In terms of frost and climate change, these are the #1 losses, obviously, for vineyards. In 2016, in the Loire Valley, they had a 30% drop in their production. There's lots of documentation every year of 30% losses in certain regions around the world just due to frost. But they can protect their vineyards via heating drums, generally frost fans or sprinkler systems, as well as climate knowledge. These pictures are from Hungary, just in the recent frost events. This costs about 4,000 euros per hectare, so it's actually very, very costly if you're going to, if you're trying to try and protect, say, 40,000 hectares. you'd be looking at 160 million just for that night of putting out the frost heating. And so this is the key component. But with climate change, what we'll see is a reduction probably in if we have an increase. So if we use, say, a 4.5 degree climate scenario, we'll have less frost days per year. And so this is actually a positive of climate change, that we're actually going to have less frost days. However, also we're going to have obviously hotter regions around moving down towards across the equator. So we'll see a movement of towards the north and towards the south of regions. However, also the technology and grape varietals are actually getting better around the world. And so the impact may not be as bad as once thought. At the moment, there are thriving wine industries in Ethiopia. So this shows that obviously in hot countries, then it can also they can be good wine growing. So this is the combined wine risk index, and we see that Mendoza in Argentina, this has earthquakes, hail, flood, the whole gambit of natural hazards every year is number one. Georgia and Moldova, these are countries that obviously have a smaller GDPs, but the percentage of their GDP due to wine is very, very high. Moldova's 4% of their GDP is from the wine industry. Up until the 2006 Russian boycott of Moldovan wines, it was up around 10% of GDP. So these are huge industries. And they are very, very vulnerable to natural hazards. So we launched the website today as well with these results at winerisk.org, and it's an ongoing project between Europe and Australian research institutions. And we will be updating it on a yearly basis. Thank you.
Thank you very much for your presentations. We'll now open the floor for questions. Are any questions from the journalists here in the room? Or from the web stream? Okay, there's one.
Hello, Boston Hunt, EOS Magazine, for Mr. Daniel. I find this extremely interesting. At the same time, I'm wondering what it's good for. If I'm a wine grower in Moldova, should I look for some other occupation? Or if I'm a wine buyer, should I buy Moldovan wine because it might be rare in the future? Mm-hmm. So those are two possibilities, but none of them seems a mainstream possibility. But what is this good for?
Yeah. I think what this risk index is really useful for is identifying, firstly, the hotspots of where the big natural hazards are. But then if you are a Moldovan wine grower, we can then look at the amount of hail days that are actually occurring. They will first get information that they wouldn't have had previously. So they can actually click on their location, they can get the number of hail days that they can expect, and then they can hopefully then make an informed decision, which we're hoping to build into the software in the future, that they could actually then see the cost benefit of putting in certain mechanisms. So if cloud seeding is shown to work from these studies, then what would be the benefit? You know, they've got this amount of production that's going to happen, and then the cost benefit associated with this. Or what they can do is they can make an informed decision to then say that on this year they're going to protect their most important vineyards, so the ones that are going to make those really sort of rare, so the really expensive wines, they'll put netting over them because it makes economic sense. But in other locations, then they just leave their vines, they take the loss, or they put in crop insurance for certain percentages of their vineyards. So hopefully they'll be able to at least get a first estimate of that, yes, I am highly at risk from hail. Maybe we haven't seen it in the last 2 years or 3 years, but this long-term study, so this uses data going back from 1900 onwards, that they will actually then, they can at least identify that they are at risk and then hopefully do something about it to mitigate it.
Follow up on that, please. I'm Mariette Leroux. I'm with Agence France Presse. Just to be sure I understand well, so yours, it's not only looking at the history of events, you're making detailed predictions year by year for what wine regions can expect in terms of hail, days, grapes?
No, so it will not be a future. It's not a future prediction of it. It's based on historical events. Then this is a long-term result of the risk index. For the next year, what we will have is we'll have the change that we've seen. So it will always be in the past, not in the future. But what this is then useful for is that they can see what they've seen in the past, and then hopefully that will trend in the future. So, yeah, or not. Yeah.
Are there any other questions? If not, you are welcome to approach our speakers and book one of the interview rooms that are available. And just bear with me for a second, because this is the last press conference, so I have to announce the large number of scientific sessions that are happening in the next few days. And I'll highlight the 2 debates tomorrow on the Arctic and on open access, and then on Friday there's one on reaching the 2-degree global warming goal. And tomorrow there's also a session on Make Facts Great Again, how can scientists stand up for science, which I hope will interest some of you. And well, thank you again. This is it for me in the press center. I hope to see you again next year from the 8th to the 13th of April. Thank you all very much for coming. Thanks very much for your presentations.